Hi, my name is Lisa Wasco-DeVetter, and I am an assistant professor in small fruit horticulture at the Washington State University Mount Vernon Research and Extension Center. Western Washington is one of the primary regions of red raspberry production. This state is the #1 producer of processed red raspberries, and it's transformed into purees, frozen fruit, crumbles. One of the major challenges for red raspberry growers is soil-borne disease management. In an attempt to solve soil-borne disease management problems that growers confront, I, as well as several of my scientific collaborators from the USDA-ARS Research Center in Corvallis, as well as private researchers and grower cooperators, have several projects looking at how to effectively control soil-borne diseases. Soil-borne diseases weaken raspberry root systems, which can impair water absorption, nutrient absorption, uptake, as well as the overall growth and development of the plant, which can reduce yields, reduce the overall productivity of a planting, and lead to an economic impact for the growers and the industry. This is why the Red Raspberry Commission, as well as other regional groups focusing on small fruits, have listed improving soil-borne disease management as one of their key priorities. One of the key soil-borne pathogens in Northwest red raspberry is Phytophthora Root Rot. What happens with Phytophthora root rot is that resistant structures in the soil called oospores, as well as sporangia that are embedded in plant tissue, release what is called zoospores. Those zoospores have flagella and can swim through the soil water film and infect red raspberry roots. Infection leads to colonization in the roots, and when it gets into the roots, it can damage and kill roots as well as the crown.
Hi, my name is Inga Zazada. I'm a research plant pathologist with the USDA Agriculture Research Service Horticultural Crops Lab in Corvallis, Oregon. Globally and in the United States, nematodes can result in severe reduction in crop yield from a diversity of plants. The type of damage that nematodes do to plants, it's not always very obvious. They nibble on roots or they invade roots. They kill roots. So oftentimes what you'll see is above ground decline of the plant and reduced yield. Some examples of that is soybean in the Midwest. There's a nematode in that crop that is actually the #1 pest of soybean in the middle of the United States. Again, that nematode will invade the roots of soybeans and cause a reduction in yield. In perennial crops such as apples, raspberries, blueberries, it's similar, it's a different nematode, but again, they either feed on the roots or invade the roots, cause root mortality, and thereby you have fewer raspberries and fewer apples. Nematodes are microscopic aquatic roundworms, so for the most case in agriculture systems, you won't be able to see them. You need to sample the soil, extract them from soil using water, and then you can visualize them under a microscope. So because of that, it's often very difficult to determine the impact of nematodes on, for example, a raspberry planting, because you don't have these direct symptoms caused by nematodes. Mostly what nematodes will do is they feed on fine roots of plants, thereby decreasing the plant's ability to acquire water and nutrients. So the symptoms you'll see in most crops, and that includes perennial and annual crops, are reduction in vigor above ground, reduced yield, and sometimes if you pull up the root system, like in raspberry, you'll see a lack of fine roots. So that will mean that there's a lot of nematodes there. They've caused mortality of those roots, and the plant hasn't been able to compensate by growing new small roots. Working in a production system like raspberry up here in Whatcom County of Washington, it is essentially a continuous perennial system, meaning that up here, raspberry usually follows raspberry. And nematodes are an important component of this production system as far as the damage that they can cause. I would say that they're probably in the top 3 or 4 pests of raspberry.
So Verticillium is another soil-borne pathogen that can be problematic in red raspberry systems. It behaves similarly as Phytophthora in terms of damaging the root system and interfering with water flow within the plant. And some growers in Northwest Washington suspect that Verticillium might be present and causing disease in their fields. However, we have no direct evidence at this time that Verticillium is a problem in Northwest red raspberry. There may be other soil-borne diseases that we are unaware of contributing to soil-borne disease problems in red raspberry and reduced vigor after replanting within the same field. However, as of present, we have no evidence that other soil-borne diseases are contributing to red raspberry replant disease complex. What replant disorder refers to is that the subsequent planting that is placed into the ground often will exhibit reduced growth and vigor, and this is attributed to both abiotic or biotic factors. Now, abiotic factors can mean anything from improper pH or changes in other physical and chemical aspects of the soil. The biological elements refer to the possible buildup of soil-borne pathogens that can result in a continuously replanted situation that can make soil-borne disease management much more difficult for a grower. Previous surveys done in 2011 and 2013 here in Whatcom County have shown that most growers are engaging in fumigation as a method to control or manage soil-borne diseases, and the number one reason they fumigate is for nematodes. In addition, the survey showed that growers are also concerned about the use of fumigants. Namely, they're concerned about the cost of the fumigants as well as dealing with some of the many regulations that entail when utilizing a soil fumigant. Growers have also expressed concern that current fumigation management practices are not leading to the results that they once saw. Now, this could be due to replant disorder and buildup of soil-borne pathogens in the soil, as well as loss of soil biodiversity that can help suppress soil-borne pathogens, but it may also be due to changing fumigation practices that are leading to reduced efficacy.
Hi, my name is Jerry Weiland. I'm a research plant pathologist with USDA ARS in Corvallis, Oregon. So one of the things that I'm seeing as a plant pathologist in this industry is that fumigation or current fumigation methods aren't working really well in controlling the fungi that are in the soil. So as an example of this, we're going through and we're testing the root material that's left in the soil after fumigation, and we're finding out that the soil fumigants aren't killing the fungi that are left in those root materials that are in the soil. So the fumigant isn't penetrating into the roots and killing fungi that are there. And this is a problem because it's a perennial crop, and these plants are exposed to this soil-borne inoculum and the inoculum in the roots for many years. So in a way, we're not getting rid of these soil fungi that are causing the problems. They're just remaining in the soil year after year and slowly building up.
So crop rotation is often an effective tool for managing soil-borne diseases. In fact, the industry in Whatcom County used to engage in crop rotation, and they would rotate raspberry crops on ground that was utilized for dairy foraging, potatoes, wheat. However, with the high value of red raspberries and a limited availability of suitable land, this is becoming less commonly practiced. So rotation is effective for controlling soil-borne diseases because many of the soil-borne pathogens are very specific to either a species or a botanical family. For example, raspberry is a rose species, so a lot of the soil-borne pathogens that infect raspberry may also have some pathogenicity on strawberry, a similar rosaceous crop. What rotations do is that by rotating the ground with a different species or different botanical family, you minimize the opportunity for pathogens to build up in the soil that have the ability to infect that crop. Most growers fumigate in the fall, and they are typically applying their fumigant through a broadcast application. Following the fumigation rig is a roller sealer, which comes behind the rig and seals the soil to try to prevent the fumigant that's been injected in the soil from escaping. Some growers are looking at bed fumigation to improve efficacy of fumigation. Additionally, tarping is utilized in a lot of other specialty crop industries, which means after a field is fumigated, a tarp is laid over that field, and it's meant to help trap and retain that fumigant within the soil, thereby helping promote that fumigant's efficacy. Immediately before fumigation, growers will often plant a winter cover crop seed. That cover crop, which is typically a winter wheat, grows throughout the winter and provides ground cover that can help provide some soil health benefits and prevent erosion. Following the winter and moving into spring, that cover crop is typically sprayed with glyphosate and terminated, and then tilled into the ground. When the soils dry out and the fields can be worked again, growers come in and start to replant their fields with red raspberry plants, which typically occurs in March. Pre-plant is typically the best time to control soil-borne diseases. However, there are some tools that growers utilize to help control pathogens in a post-plant situation, and those include post-plant fungicides as well as post-plant nematicides.